Hello, ladies and gentlemen. Welcome back. All right, now our topic is on something called coterminal angles. All right, so first off, what happens when you spin around the origin more than once? Can you even do that? Yeah, you totally can. Imagine any sport in which they spin around, okay? Snowboarding, figure skating, skateboarding, if I haven't mentioned that. All of those different situations in which someone spins around multiple times, even if you just got up in the cafeteria and spun around, did a twirl, right? You're spinning around 360, 720, right? And so on and so forth, 1080. So those are all coterminal. Now here's the thing that matters for that. Coterminal angles, and this is what we're going to talk about today. Coterminal angles are angles of different rotation values that share a terminal side. Okay, now you might be thinking, Mrs. Fry, you're really throwing the math language at me. What do you mean? Okay, let me give you an example. Suppose we were looking at, and I'm not going to pick something in the first quadrant because that's just that's been done. Let's say we were here, okay? This angle that I just drew you, I'm trying to make roughly 120 degrees, okay? So, suppose I told you that instead I wanted to draw the angle 480 degrees. Well, here's what you would do. You would think, well, 480 is going to go all the way around once. So it's going to go all the way around. But then after it goes all the way around, it still has to go another 120 degrees, which would land it in the exact, to the best of my sketching ability, in the exact same position as the 120 degree angle. It just has this little extra spin from the first 360 degrees. All right? Now, the same is true if we went backwards. Okay? I could ask you to write the angle like a negative angle. I could ask you to take negative 240 degrees and draw that. And basically, all that would be is starting here and working backwards. This is why that directional arrow is so important. Okay? So, how do you determine where coterminal angles land, what a coterminal angle might be to another angle? Well, here's the deal. If you're in degrees, in general, you want to add or subtract 360 degrees. And if you're in radians, you're going to want to add or subtract 2 pi. Now, keep in mind, depending on the value of the angle, you might have to add more or subtract more. But just to give you an idea of some other terms that we're going to talk about, if my starting angle was 120 degrees, then 480 degrees is a positive coterminal, and the negative 240 degrees is a negative coterminal angle. And guys, it's not anything fancier than the reason why we use the word positive is because it's a positive angle. It has a positive rotation. We used the word negative here because it's a negatively rotating angle. Okay, so when we're looking for coterminal angles, we're looking for ones that rotate differently, more or less positive and negative. All right, so we're going to do a couple of examples right here. Now, I'm going to literally find the positive and negative coterminal, and then I'm going to talk about just how you would draw the original angle and how its reference would look. And you know what I'm going to do? I'm going to give myself a little bit more space because I think that we're going to need that. So hold on one second while I create a All right, so like I said, first thing I'm going to do is I'm going to find a positive or negative coterminal angle. So positive and negative coterminal angle. Now, since I'm in degrees, I'm going to see what happens when I add 360. Now, I get it. You're like, oh my God, I got to do this without my calculator. Guys, you can totally handle it. Just think about the difference between those two values. You know it's going to end in a 5, right? So take a moment, think about that. I promise you can figure it out. All right, did you get negative 75? Because it's got to be less than 100. All right, now because that number is negative, we found a negative coterminal angle. All right, I'm going to add 360 again, and let's see if we can get a positive angle this time. All right, 360, if I'm subtracting 75, that's going to be 285. Yeah, 285. Just had to double check my math there, thinking for a second. See how this is a positive angle? That makes this our positive coterminal. So, to recap, we have the angle negative 435 degrees, and then it has a positive coterminal at 285 degrees and a negative coterminal at negative 75 degrees. Now, what would this angle look like if I went to draw it? Because that's another skill we need to practice. Well, for starters, it's negative, so it's going to start going down. And since it's larger than 360 degrees, it's going to rotate once around negatively. And then, as we just discovered, it's going to go 75 degrees more into the first quadrant. So that angle is going to look like this. So to recap, we've got the direction going around and ending right here. Okay, this is our angle drawing. And then the last question I had for you guys was, what's the reference? And the reference is this value right here, this distance. So the reference angle would be 75 degrees in this situation. All right, we're going to do one more problem with degrees, and then we're going to take a look at radians. Okay, so you guys find those two coterminal angles. All right, in this case, I think it's going to help by starting out with 640 and subtracting 360. All right, so you see if you can find those two angles, and then we'll go from there. All right, ladies and gentlemen, so look at that technology magic. So I got 280 degrees and negative 80 degrees for our positive and negative coterminal angles. Now, I still want to draw the original angle. So the original angle is 640 degrees. That means I'm supposed to go all the way around once, and then I'm supposed to go all the way to where 280 would land. So that's somewhere in the fourth quadrant, right about there. So this is a 640 degree angle drawn in standard position. All right, now let's take a look at what happens when we are talking about things in radians. So that's going to be a little bit different. Again, I'm going to start with finding my positive and negative coterminal. Now keep in mind, I had mentioned that that's add or subtract 2 pi. Right now I have a positive number, so that's why I'm subtracting. So the first thing I think is, okay, I'm going to subtract 2 pi because that'll make this smaller. The only problem is, right now 2 pi doesn't have a common denominator because this is 2 over 1. So instead of 2 over 1, I'm going to think of something over 3. Well, that would have to be 6 over 3, because 6 over 3 is the same as 2 over 1. Those are equivalent fractions. Now, I just need to subtract my numerators, so I get 5 pi over 3. I got to tell you, once you think about that, in my opinion, the radian ones are way more straightforward. So, 5 pi over 3, this guy, that's our positive coterminal. All right, so then I'm going to stick with that 5 pi over 3, and I'm going to subtract 6 pi over 3 from it, and that's going to get me negative pi over 3, and now I've found a negative angle. So now I have a negative coterminal angle. Ta-da! Okay, but we still need to practice a little bit of drawing. So hopefully you left yourself some space for this. So 11 pi over 3. It goes around one full rotation because I needed to take a 2 pi out. And then it still goes another 5 pi over 3. Now this can be a little tricky. Here's what I can tell you. This is half of a pi, 1/2. So you know 5/3 is bigger than 1/2. 5/3 is still bigger than 1 pi, so you know it's not here. Here's the tricky part. Is 5/3 bigger than 3 over 2? And the answer is yes. Because 5 divided by 3, and if you need to take out your calculator just to like check on that, I guess that'd be okay. 5 divided by 3 is 1 2/3, and 2/3 is bigger than 1/2. So that's going to land right here, okay? That is the angle, sorry, not the angle 5 pi over 3. That's the angle 11 pi over 3. All right, one full rotation around plus another 5 pi over 3. Okay. Last one I'm going to do for you, and then you guys are going to take some time to just practice. So first off, anytime you get a fraction, I'm looking at D, and 20 over 6 doesn't feel right. Let's reduce that. Negative 10 pi over 3. All right, already we have a more manageable angle to deal with. Now, just like the last one, we're over 3, but this time we have a negative as a starting point, so I'm going to add instead, and I'm going to add 6 pi over 3. And that's going to get me negative 4 pi over 3. All right, so it looks like I've found my negative coterminal angle. I'm going to pick back up with that negative 4 pi over 3, and I'm going to add 6 pi over 3, and that's going to get me 2 pi over 3. This angle is my positive coterminal. But again, I still want to make sure I'm drawing that angle. Okay, so to draw that angle in, here's my initial side. So I've got to go all the way around once, 6 pi over 3, and then I still need to go negative 4/3. So that means I need to go 1 1/3. So that's going to land me in this second quadrant. Okay, now, so this is the drawing of negative 10 pi over 3. Now, one last thing to talk about these before you take a little bit of time to practice is that reference angle item, okay? So this can really like stress people out. But remember, the reference angle, wherever you land, it's just back to the x-axis. So in this case, our reference angle would be pi over 3. Because remember, we went to 1/3, so we must have pi over 3 left. All right, and then over here, same thing. Pi over 3 is my reference angle. I can't remember if I did that on the last two guys. Here, let me take a quick check. Oh, I did it on A, but I didn't do that for B. For B, our reference angle is going to be this distance. So that's going to be 80 degrees because we went to like 640, which was the same place as 280 or negative 80. And so that distance must be 80 degrees. So that's our reference angle there. All right. Now, I've done a ton of talking at you without any time to really just pause and practice. So I want you to take a moment and pause, and I want you to try E and F, okay? And remember, you're going to find the positive negative coterminal and then draw them to help you figure out the reference angle, okay? So if you haven't paused, do that right now. I mean it, go try these out. All right, welcome back. So here's the deal. Here are, and I do want to point out, I haven't mentioned this yet in the video, there are lots of positive and negative coterminals angles. There's an infinite amount, guys. It's like insane. We could do one problem forever. We're just finding the closest ones, okay? So taking a look at those answers, now we're going to take a look at our graph. So I'm trying to graph negative 35 pi over 12. So negative 35 pi over 12. When I added one rotation, I was still negative 11 pi over 12. So I still need to go almost all the way around to here, okay? So then this, let me point out, this rotation, all of that, that represents the angle negative 35 pi over 12. This little sliver right here, theta being 1/12 of pi, that's my reference angle, okay? Because that's what's left to finish out my rotation. And then over here for problem F, I am starting right here, and then my angle is going to go, so I was at negative 540, so I'm going around once, and then I still am supposed to go around one more time to negative 180, so it lands back here. So, and this is going to sound a little weird, reference angle is 0. It's kind of weird. I know, it doesn't happen too often. It's just landing on the axis, so it does whatever 180 does. So this is the graph of negative 540 degrees. All right, 2 more problems for you to try, okay? If you haven't tried I and J, or I should say the ones right below this, F, A, F, G, and H. Turns out they're the same problem, guys. Slight typo in the notes. Mea culpa, my apologies. So if you haven't tried the last 2 problems in your notes for this section, please do that right now. No, seriously, you don't need me to do them. You got this. All right, thanks for pausing. Welcome back. So here are your last 2 problems. All right, and once again, I'm going to draw these out for you. Hopefully you did that already. Okay, so we are drawing our initial ray. 820 degrees, that's our goal. We're going around once positively, and then we were still at 460. So we're going around again, and then we want to, oh guys, that was not my best swoop. All right, swoop once, twice, and land just past 90 degrees because we want to land where 100 degrees lands. And guys, that's also part of the reason why we find coterminal angles, because like I don't have a clue where 820 degrees lands just off the top of my head, but I do know where some of those smaller angles land, and so that's what helps me out. All right, and then last but not least, 15 pi over 4. All right, so we're doing a positive rotation, so it looks like we're going to go around once, and then I need to get to 7 pi over 4, so it means I need to go most of the way around and land in the 4th quadrant, okay? So, and the way you know that you're going to land close to that 4th quadrant, so this is 3 pi over 2, and this is 2 pi. 7/4 as a fraction is closer to 2, right? So you know you're going to land in the 4th quadrant. That's a big hint, in my opinion, right? Because 7/4 is almost 2. So you're definitely in that 4th quadrant. All right, folks. Thank you so much for listening. Hopefully this really helped you understand how to draw angles and how to find those positive and negative coterminals. Ooh, to close this out, I know I'm saying goodbye, but I just realized I keep forgetting this. I'm sorry. Reference angle right here. If we are at sort of 100 right there at this spot, then this must be an 80-degree reference angle left over. And right here, if we were at 7 pi over 4, then that reference angle must be pi over 4. All right, now for real. Adios. Have a good one, folks. Bye.